Okay, so in this video, we are going to solve some exponential equations. Now, we're not going to use anything clever like logarithms or anything like that. We're just going to use our brains. So let's get stuck into it. We'll start off with it being nice and simple, and we will progressively make it more complex. So 2 to the x equals 16. Okay, so we need to think, well, what power of 2 is 16 going to be? Of course, 2 to the power of 4 is 16, right? Okay, well, this tells me straight away that x is going to be 4, right? Now, perhaps you prefer it if we did this in a sort of a more logical step. So maybe the best way to say is actually the 16 is 2 to the power of 4. So write it out like that, just directly underneath. Then we can drop the 2's, can't we? 2 to the x equals 2 to the 4 means x is 4, and we're done that way. Okay, let's use that technique then to do part B. Well, I've got a power of 3, look here, and I recognize that I could probably write 1 over 27 as a power of 3 as well. So let's use that technique again. Let's write that as a power of 3, and then we can drop those base numbers. So we're going to say 3 to the x plus 2 is equal to, and remember 1 over 27 is 3 to the minus 3. So that means we can drop those bases and say x plus 2 equals minus 3. Now I'll take 2 from both sides. X is minus 5, and we're done. Let's move on, see if we can work out some more complicated ones. So here we have a 4 to the x and an 8. And when I'm seeing 4 and 8, I'm thinking about bases of 2. So let's write both sides for base of 2 and use that technique of dropping those bases again. Right, so 4 is 2 squared. So on the left-hand side, we could certainly write that. 8 is 2 cubed. So on the right-hand side, we can write that. We can bring the 2 exponents together on the left. We can say it's 2 to the 2x equals 2 cubed. And from here, we can drop those bases and just say, therefore, 2x equals 3. That means that x is 3 over 2. Let's take a look at something like that. Again, if you saw a previous video, it looks a bit quadratic-y, doesn't it? Let's try to convert this into a quadratic that we can solve using quadratic techniques. So I'm going to try to make an exchange. I'm going to say 2 squared to the x, well, 4 to the x is 2 squared to the x, and then I'm going to rewrite that as 2x squared. Okay, so I'm interchanging those because we're multiplying. 2 times x is the same as x times 2. So that's going to allow me to rewrite the original equation as 2 to the x squared plus 2 to the x minus 20 equals 0. Now, why would I do that? Well, because I can see a quadratic here. Think of this, right? Imagine that 2x, let's write it down, 2x is equal to a y. Well, what I've got then is y squared plus a y minus 20. Do you see what I've done? And now I can factorize it like I would any other quadratic. Let's write it, let's use the red pen and think about it in terms of y. What 2 numbers multiply to make minus 20 and add to make 1? Well, we're going to have a positive 5 and we're going to have a negative 4. So therefore, our solutions are y is equal to minus 5 or y is equal to 4. But of course, we made up y. Y is 2 to the power of x. So we can say 2 to the power of x is equal to minus 5, or 2 to the power of x is equal to 4. Now, there is no number that generates a minus 5 here, right? I think that is absolutely impossible. So let's get rid of it, okay? No solution found that way. However, this one works. What are we going to have? Well, 2 to the x equals 2 squared, because 4 is 2 squared, which means we can drop those bases again. And we find that the solution to that equation was x is equal to 2. Okay, hopefully this has given you some understanding of how you can solve some exponential